Welcome. So in this video, we're going to be working through question 2 of exercise 18F. Let's give it a read. It says a particle moves in a straight line, so its position x centimeters relative to the origin at time t seconds is given by this right here. X is equal to t squared minus 12t plus 11, where t is greater than 0. The first thing that I would want to take note of is that is the same position equation I was given from part 1. As you can see, it's the same. So all of this information is going to be relevant to us, and of particular relevance is going to be this little sketch that we drew. I'm going to be referring to this throughout this video. So let's now see if we can answer part A, which says find its initial velocity. Okay, so if we're finding the initial velocity, what we're going to be doing, let me just quickly grab the right pen here. So this is A. What I'm going to do is I'm going to differentiate this position equation right here. So my velocity is equal to dx dt. I'm differentiating x with respect to t. That's going to be 2t minus 12. Now it says it wants its initial velocity. Well, that means when t is equal to 0. So when no time has elapsed. So its initial velocity. So that means I'm going to go v is equal to, and just let t equal 0, 0 minus 12. V is going to be equal to negative 12 here. Now, it's important that we just don't generate numbers, but we also explain what they mean. So what does this velocity being equal to negative 12 mean? It means the particle is moving. The particle is moving to the left. And the reason why I know it's moving to the left is because it's negative. And then we can say at 12 centimeters a second. So all that there is very irrelevant to us. The velocity is also telling me the direction in which it's moving. So the particle is moving to the left at 12 centimeters a second. Perfect. Let's now move on to part B here, and let's see what it has to say for itself. Let's do that. Let's grab our highlighter. Remember, in a test or even these questions in your textbook, make sure that you're underlining keywords. When does its velocity equal 0? So what does that mean? That means when is it stationary? If the velocity is equal to 0, it means when is it stationary? And what is the position at this time? Okie dokes. So what we're going to do here is I'm going to take my velocity and I'm going to set it equal to 0 and solve for t. And I'm finding where I'm going to be instantaneously at rest. Again, when you just see the word velocity, it's talking about its instantaneous velocity. Only when it specifies with regards to part C, where it says average velocity, do you know it's talking about the average. When it's just velocity by itself, it's referring to the instantaneous velocity. So what I'm going to do is I'm going to take my velocity, which was 2t minus 12, 2t minus 12. I'm going to set that equal to 0, and I'm going to solve for t. Well, that's going to be 2t is equal to 12. T is going to be equal to 6. That tells me at t is equal to 6, the particle is stationary. Perfect. Because that's what it means, what it says, like v is equal to 0. When the velocity is equal to 0, it means it's stationary at that point. And it also wants the position at this time. Well, to find the position at this time, what I'm going to do is I'm going to say, well, t is equal to 6, and I'm going to sub that into my position equation. So I'm going to go x is going to be equal to 6 squared minus 12 6 plus 11 is equal to 36 minus 72 plus 11. Then I keep on going. 36 plus 11 is 47 minus 72. This is going to end up being negative 25. All right, good. Now let's kind of bring all of this together. We know that when t, well, I didn't want to highlight that in green. Yuck. There's still a bit more there. Thank you. So that means when the time is 6, so at t equals 6, the particle is stationary, and the position at which it's stationary is negative 25. So again, it's really important that when you're doing these questions, you're not just writing down mere numbers, but you're explaining what they mean. So what I would say is when t is equal to 6, the particle, now instead of just saying stationary, what if I said the particle is instantaneously at rest? And then I'm going to mention its position, 25 centimeters to the left of the origin. because it's negative 25. So at t is equal to 6, the particle is instantaneously at rest 25 centimeters to the left of the origin. Fantastic. If I was to come up here now and just kind of visualize this, booped, booped, booped. I know, actually I need to get a red, sorry, it takes forever to change colors. This is going to be negative 25 here, and I know, no, I don't want to do that. I know that I started here, this is my initial position, 11 centimeters to the right of the origin, and I'm moving this way, and I stop here. I stop at negative 25, and the time at which this occurs is at t is equal to 6. So after 6 seconds, I'm stationary at this point right here. I'm stationary. At t is equal to 6. Perfect. All right. Let's keep on moving. Let's keep on moving. What is its average velocity for the first 3 seconds? Okie dokes. All right, so we have to know what average velocity is. Average velocity, and this is something that you just have to memorize, means the change in position over the change in time. Okay, change in position over the change in time. Can I write that a bit nicer? Give me 1 second. Change in position. Change in time. Okay. Now it's for the first 3 seconds. Now if it's the change in position, guess what? I'm going to be using my position equation here. So I'm going to say when x is 3 minus when x is 0. So in other words, when t is equal to 3 to when t is equal to 0, the positions of those, and then it's just 3 minus 0 because it's the change in time. So this is giving me the change in position. This is giving me the change in time. Now, I know what x of 3 is because we did it in part 1. Now, can I remember? No. So I'm going to have to come up here. When t was equal to 3, x was equal to negative 16. Thank you very much. Negative 16. And then when x is equal to 0, sorry, when t was equal to 0, x was equal to 11. So this is going to be minus 11. And then it's going to be 3 minus 0, which is 3. This is going to be negative 27 on 3, which means what is going to be my average velocity is negative 9 centimeters a second. So notice that it's a negative value. Really take note of the fact that it's negative. That tells me the position in which it's moving. It's moving to the left. And I know that because it's negative. So take note of that. So if we look here for a second and picture where I'm moving from, I'm going from here to t is, oh, that's too thin. To t is equal to 3, which is at negative 16. And I'm saying from here to here, my average velocity is negative 9 centimeters a second. And notice how that's also giving me the direction it's moving in as well, that negative. All right, that's average velocity. We now come to comparing that. So we just did average velocity. We now want to determine its average speed for the first 3 seconds. What's the difference between average velocity and average speed? So we're doing now CD, and we're talking about the average speed. Now the average speed is the, let's zoom in here, change in distance over change in time. The change in distance. So what we need to figure out to answer this question is what is the total distance traveled? So not the difference in the position, but the change in the distance. Well, if I'm starting at 11 and I'm going to 16, well, from here to 0, that's 11. And then from 0 to, oh, that is horrible. That is just atrocious. You know what I mean. From 11 to 0, that's 11. And from 0 to negative 16, that's a distance of 16. So it's just going to be 16 plus 11. So just make it a bit nicer. Come down here. 11 plus 16, which is 27. So that means it's 27 on 3, because it's still in 3 seconds, right? And actually, let me do this a bit nicer. 11 plus 16 over 3 minus 0 is 27 on 3. I'm still not going to get there. Is equal to 9 centimeters a second. So that's what it's going to be. 9 centimeters a second. So you might be wondering to yourself, how is that different to this average velocity? And hopefully you can see that my average velocity had a sign when my speed doesn't have a sign. It's always positive. So the average velocity is also going to tell you the direction. But what we can say after all of this is the particle moved to the left for the first 3 seconds. It doesn't change direction. And the speed at which it's traveling at is at 9 centimeters a second. Now, you can imagine that, things would be different if there was, we're involving like going around the stationary point, which we'll get to that. We'll get to that. So as long as you understand this, and that for this question, this is what's happening. So question 1 and 2 are very much related. I wonder if question 3 will be related. I do not know. I have not looked at it yet. Hopefully you enjoyed this video. Hopefully you kind of made sense of what's happening. It took me 11 minutes to record, nearly 12. I'll see you in the next video.